We are going to use properties to generate equivalent expressions. To be able to do this, we must first understand what the properties say. We're going to look at addition properties first, followed by multiplication. So the first property of addition is the commutative property of addition. The commutative property of addition tells us that we can add numbers in any order and get the same answer. So this is something like x plus y is equal to y plus x. We can show this numerically by saying something like 8 plus 12 is equal to 12 plus 8. We know that this is true because if we add 8 plus 12, we get 20. And if we add 12 plus 8, we also get 20. Well, even though we changed the order from 8 plus 12 to 12 plus 8, we still have the same answer. So even though these look different, these are equivalent expressions. Next, we have the associative property of addition. The associative property of addition tells us that we can group numbers that are being added in different orders or in different groups, and they will still give us equivalent answers. So an example of this would be a plus b plus c equals a plus b plus c. Now that sounds similar, but if you notice on the first side, we have a plus b grouped together in parentheses, which means that you would technically need to add those first and then add c second. Over here, we're saying that we're going to add b plus c first because they're in parentheses and then add a. Even though these are grouped together differently, they would still create equivalent expressions. A numerical example of this would be 1 plus 3 plus 2 in parentheses is equal to 1 plus 2 in parentheses plus 3. On this side, I would add 3 plus 2 first because they're in parentheses, and 3 plus 2 would give me 5. Then I would add 1 plus 5, which would give me 6. On this side, I would add 1 plus 2 first because they're in parentheses, so 1 plus 2 gives me 3. And then I would add this 3, which would also give me 6. So even though my numbers are ordered differently or grouped differently, the associative property says that they are equivalent expressions. Next, we have the identity property of addition. The identity property tells us that if we add 0 to a number, we're going to get the same number because any number plus 0 is itself. This is like saying 53 plus 0 is equal to 53. Next, we're going to look at the properties of multiplication. The properties of multiplication are the same as addition. We have the commutative property, the associative property, and the identity property. The commutative property tells us that we can multiply numbers in any order. So algebraically, this would mean if I do x times y, that is the same as saying y times x. This might mean 5 times 3 is equal to 3 times 5. You notice that the order of the numbers is changed, but their value does not, because 5 times 3 is equal to 15, and 3 times 5 is also equal to 15. The associative property of multiplication, just like the associative property of addition, tells us that we can group our numbers in different orders and still get the same answer. So this means if I do a times b, then multiply by c, that's the same as doing b times c first and then multiplying by a. So an example of this would be 4 times 2 first multiplied by 5, which is the same as 2 times 5 first multiplied by 4. And I know this is true because if I do 4 times 2 first, because it's in parentheses, that gives us 8. And then 8 times 5 gives us 40. On this side, I would do 2 times 5 first because they're in parentheses. 2 times 5 would give me 10, and then I would multiply by 4, which would also give me 40. Finally, the identity property of multiplication tells us that when we multiply any number times 1, we get that number. So an example of this would be 96 times 1 equals 96. Now we're going to look at the distributive property, which is a special property that combines multiplying and adding or subtracting. For this, the distributive property says that if I have a sum or a difference, in this case b plus c, and it is being multiplied by a number, in this case a, that's the same as saying a times b plus a times c. So what we do is distribute our a, or our value out here, to every addend in our parentheses. An example of this is 3 times 5 plus 4. Now typically we know that what we would do with a problem like this is add 5 plus 4 because it's in parentheses. And that would give us 9, and then we would multiply 9 by 3 and we would get 27. But the distributive property tells us that this is the same as saying 3 times 5, and then because there's a plus sign here, plus 3 times 4. And we can check this by seeing if it is equivalent to 27. Well, if I do 3 times 5, that would give me 15. And 3 times 4 would give me 12. If I do 15 plus 12, that does give me 27. So the distributive property tells me I can take this and I can distribute my 3 to everything inside my parentheses. Next we have 9 times 4x plus 2. In this problem, you notice that we have a variable. So we cannot combine 4x plus 2 because we don't know what 4x equals. This is why we need to use the distributive property. So I would distribute 9 to 4x. So if I do 9 times 4x, 9 times 4 is 36. So 9 times 4x is 36x. Then I'm going to multiply 9 times 2. When I multiply 9 times 2, I get 18. So I'm going to write plus 18. Now I want to know how I can generate equivalent expressions. This problem says, which expressions are equivalent to 8m plus 9m? Well, the first thing I want to know is, what does 8m plus 9m equal? I know that these are like terms, so I know that I can combine them. So I can do 8m plus 9m, and I would add 8 plus 9 to get 17, and I would keep my m. So 8m plus 9m equals 17m. So I know that 17m is definitely an equivalent expression to this. But what about 3m plus 6m plus 5m? Well, I notice for this that all of these have the same variable, so I can combine them. So I would do 3m plus 6m, which is 9m, and then 9m plus 5m, which is 14m. Well, that's not the same as 17m, so this is not an equivalent expression. What about 18m minus m? In this case, I notice that I have like terms, m and m, so I can combine by subtracting, but it looks as if I don't have a coefficient here. However, I know that anytime I don't have a coefficient, there's actually an invisible coefficient of 1. So this is like saying 18m minus 1m. And 18m minus 1m is 17m. So this is the same as this, which means these are equivalent expressions. Now let's find equivalent expressions to 4 times 2j plus 3. First thing I want to do is simplify this, and I notice that I have a 4 being multiplied by a sum of 2j and 3. Because it's multiplying by a sum, I know that I should probably use my distributive property. So I'm going to multiply 4 times 2j, which would give me 8j, and I'm going to multiply 4 times 3, which would give me plus 12. So I'm looking for expressions that are equivalent to 8j plus 12. Well, what about 20j? It looks like that could work because if I add 8 plus 12, that gives me 20. But the problem with that is that 8j is not a like term to 12 because 12 does not have a j with it, so they cannot be combined. So actually, my simplified expression is 8j plus 12. Which means 20j is not equivalent to that. Well, 8j plus 12, we know that that's correct. What about 6j plus 2j plus 12? For this, I would need to combine all of the like terms. I have 6j plus 2j. Well, those are like terms because they both have the same variable, j. So if I do 6j plus 2j, I'm going to get 8j. And then I still have this plus 12 in my expression. And now there are no more like terms, so that is simplified as far as it will go. Well, if you notice, these are the same expression. So this is also an equivalent expression. Now let's look at 5 times r plus 3. Again, I'm multiplying 5 by a sum, so that means I can use the distributive property to simplify. So I'm going to multiply 5 times r. Well, when I multiply 5 times r, remember there's an invisible 1 here. So it's 5 times 1r, which is 5r. And then it's 5 times 3, which is 15, so plus 15. So I'm going to look for any expression that is equivalent to 5r plus 15. Well, my first expression says 5r plus 3. I know that that's not correct because if somebody did this, it looks like they probably distributed the 5 to the r, but then they forgot to distribute it to the 3. What about 3 plus r times 5? This is still a sum being multiplied by a number. So for this, I can still distribute my 5. So I would distribute 5 times 3, which would give me 15, and 5 times r, which would give me 5r. Well, is that equivalent to 5r plus 15? Yes, because we know that the commutative property tells us that we can add in any order. So if this expression says 5r plus 15, and this expression says 15 plus 5r, we know that those are the exact same. What about 4r plus 12 plus r plus 3? For this, I would want to combine any like terms. Well, I notice that I have 4r and r. Those are like terms because they have variables that are the same. If I add 4r plus 1r, that gives me 5r. And next I have constants. Any constant is considered a like term because I can add them together. So I have 12 plus 3, and 12 plus 3 gives me 15. So this would be 5r plus 15. Well, that's the same as this, so this is also an equivalent expression.